This is a video on using the first fundamental theorem of calculus. The question is to evaluate the integral from 1 to 4 of the square root of x minus 1 divided by the square root of x dx. We will use the first fundamental theorem of calculus, which states that the integral from a to b of f of x dx is equal to capital F of b minus capital F of a, where capital F of x is the antiderivative of little f of x. So first I'm going to take my integrand and I'm going to convert the square roots into exponents. Remember, square root of x is the same as x to the 1/2. And when we have a 1 over, we can rewrite that as x to the negative 1/2. So what I get is the integral from 1 to 4 of x to the 1/2 minus x to the negative 1/2 dx. Next, I'm going to use the power rule that says when I want to find the antiderivative of x to a power, I take x to the power plus 1 divided by the power plus 1. So 1/2 plus 1 is 3/2, and negative 1/2 plus 1 is positive 1/2. So what I get is x to the 3/2 divided by 3/2 minus x to the 1/2 divided by 1/2. And I'm still going from 1 to 4. So let me just simplify this. Dividing by a fraction is multiplying by the reciprocal. So what I get is 2/3 x to the 3/2 minus 2 times x to the 1/2. Notice 1 over 1/2 is the same as 2. The next step is to plug in. We want f of b minus f of a. That means I'm plugging in 4 and then subtracting what I get when I plug in 1. So I plugged in 4 and I plugged in 1. Now 4 to the 3/2 is the same as the square root of 4 cubed, or 8. So 8 times 2/3 is 16/3, and 4 to the 1/2 is the square root of 4, or 2, and 2 times 2 is 4. So I get 16/3 minus 4. 1 to any power is just 1, so I just get 2/3 minus 2. My last step is just to do the arithmetic. What I got when I subtracted this out was 8/3. And I'm done with the problem.